Let's take a look at section 5.1, where we're going to look at the greatest common factor and the process of factoring by grouping. So let's talk about a few ideas and definitions before we start. Okay, so factor as a noun, a factor is one of the numbers or expressions being multiplied to form a product. So when we use the word factor as a noun, that's what we mean. One of the numbers or expressions being multiplied to form a product. As a verb, factor means to write the polynomial as a product. So the process of writing a polynomial as a product is what we mean when we use the word factor as a verb. The greatest common factor of a group of integers is the largest integer that divides evenly into each integer in the group. The greatest common factor, also known as GCF, of a group of monomials is the monomial with the largest coefficient and the highest degree that divides each monomial evenly. So when we're finding the GCF of a group of monomials, we want that monomial to have the largest coefficient and the highest degree that divides each monomial evenly. The GCF of a polynomial is the expression with the largest coefficient and highest degree that divides each term of the polynomial evenly. So when we want to find the GCF of a group of integers, we will write out the prime factorization for each integer in the group. We write down the prime factors common to all the integers in the group. We multiply the common prime factors listed in step 2 to find the GCF. If there are no common prime factors in step 2, then the GCF is 1. So let's follow the 3-step process to find the GCF of 90 and 300. So 90 is equal to 3 times 3 times 2 times 5. So that's the prime factorization of 90. The prime factorization of 300 is 2 times 3 times 2 Actually, 2 appears as a factor twice. So 2 times 2 times 3 times 5 times 5. So that's our prime factorization for 300. Now in step 2, we want to write the common prime factors. So we see that 2 appears as a factor in 90 and appears twice as a factor in 300. So that means we can only write 1 2 in the GCF. Only a single 2 appears as a common factor. 3 appears twice as a factor in 90, once as a factor in 300. So we write 3 once as a factor in the GCF. And then 5 appears once as a factor in 90, twice as a factor in 300. So we write it once as a factor in the GCF. So 2 times 3 times 5 is 30. Alright, so this is a pretty easy one because you can pretty easily probably look at 90 and 300 and see that 30 is the largest number that divides into 90 as well as 300. If these were numbers that you couldn't see so easily, what we are showing here is the process you would use to find the GCF. So we want to find, when we're finding the GCF of a group of monomials, we want to find the GCF of the coefficients of those monomials. So we want to do that first. Find the GCF of the coefficients. Then we want to find so we're going to use the lowest appearing power for each common variable factor. So that's actually going to be the highest power on that variable that divides evenly into each monomial. So the GCF is the monomial with the coefficient from step 1 and the variable factors from step 2. Alright, so let's use this to find the GCF of 90x cubed y to the 5th and 300x to the 4th y cubed. Well, we already know the GCF of the coefficients is 30. So the GCF of the coefficients equals to 30. We found that previously. Alright, we see we have the variables x and y. So there's x to the 3rd in the first term and x to the 4th in the second monomial. So the first monomial has x to the 3rd, the second monomial has x to the 4th. So the lowest power that ever appeared on x is the power that goes on x in the GCF. We have y to the fifth in the first monomial, y to the third in the second monomial. So the lowest appearing power is the power that goes on y in the GCF. So the GCF has a coefficient of, so the GCF of 90x cubed y to the fifth and 300x to the fourth y cubed is 30 x cubed y cubed. So notice that's the largest coefficient and the term with the highest power that divides evenly into both of these monomials. So when we want to factor out the GCF from a polynomial, we're going to find the GCF of all terms in the polynomial. We're going to write each term as a product that includes the GCF. We're going to use the distributive property in reverse to factor out the GCF. And then we can always check our answer. So let's use this process, this four-step process, to factor out the GCF of the polynomial 90x cubed y to the fifth plus 300x to the fourth y cubed. We already know that the GCF is 30x cubed y cubed. So we're going to rewrite this so that each term is the product of 30x cubed y cubed. And let me use color on this. The product of 30x cubed y cubed and some other expression. And in the first position, 30 needs to be multiplied by 3 for me to get 90. X cubed is already present in the GCF, and y cubed needs to be multiplied by y squared for me to get y to the fifth. So the second term is also going to be written as a product of 30x cubed y cubed times whatever's needed, so that I get 300x to the fourth y cubed. And obviously I have to multiply the 30 by 10 to get 300. X cubed times x to get x to the fourth. And y cubed is already present in the GCF. So I see I have this common GCF factor of this expression that I've written, where I have the GCF written in red. So I've actually written, really I've done step 1 and step 2 here. So this really is step 2. Step 1 we had done already because we had already found the GCF was 30x cubed y cubed. And in step 2 I was supposed to write each term as a product that includes the GCF. So this is really step 2. Got a little bit ahead of myself here. Step 3 is to use the distributive property in reverse to factor out the GCF. So 30x cubed y cubed is a common factor to both terms. And I'm going to multiply that by 3y squared plus 10x. And if I check this, I see that 30x cubed y cubed times 3y squared is 90 x to the fifth, x cubed y to the fifth. Thirty times 10 is 300. X cubed times x is x to the fourth. And y cubed is just recopied. So I see that that does indeed equal the polynomial that I started with. So it does check out. So this is my original polynomial. Alright, so a lot of times this second step we actually do mentally. Alright, so we want to use this same idea to factor a polynomial by grouping. So I'm going to group the terms with a common factor. It may be necessary to rearrange the terms. For each group, factor out the greatest common factor. Factor out the common binomial factor if there is one. Now, in our previous example, our factor was always a monomial. Now our common factor, once we do step 1 and 2, is going to be a binomial factor. And again, we can check our answer by multiplying out the factors. The check is going to be optional, but it is always something you can do to see if your work is correct. So let's use this 4-step process to factor this polynomial by grouping. So I'm going to group 14xy plus 6x squared together. And I'm going to group 35y squared plus 15xy together. So when I look back at my process, that's my first step, is to group terms with a common factor. So I see that the greatest common factor of 14 and 6 is 2. Both terms contain an x. The lowest power that appears on x is 1. So that's the power of x in the GCF. So the GCF of these first two terms is 2x. So for each group, factor out the greatest common factor. So this is the GCF of the first group. So 2x is multiplied by 7y in order for me to multiply this GCF by the appropriate expression so that I get this first term back. 2x has to be multiplied by 3x to get the second term. Alright, now if this is going to work, I want to factor the GCF out of the last two terms that multiplies with 7y plus 3x. It may be that this isn't going to work for this problem, but if it does, the GCF that I put in this position will also multiply by 7y plus 3x. So 7y needs to multiply by 5y to get 35y squared. And then we check, is 5y times 3x 15xy? And we see that it is. So notice I have a common binomial factor of 7y plus 3x. And I'm just doing the distributive property here, but I'm doing it in reverse. In first position, 7y plus 3x is multiplied by 2x. In second position, 7y plus 3x is multiplied by a positive 5y. And so this is actually my final answer. That's my factorization. This is called factoring by grouping. Now if I want to check it, 7y, so here we're going to do the check. So 7y gets multiplied by 2x. 7y gets multiplied by 5y. Three x gets multiplied by 2x. 3x gets multiplied by 5y. So this is 14xy plus 35y squared plus 6x squared plus 15xy. And if we want to, we can of course rearrange these terms to get our original polynomial. And there we go, that's our check. So we see, I'll just put a check mark by this, indicating that it is the original polynomial that I started with. So remember, the check will be optional. Alright, so that's our 5.1 worksheet. Factoring out a GCF as well as factoring by grouping.